Hi friends, if you toss a coin, what is the chance you'll get a heads? Or if you roll a dice, what is the chance you'll get a 6? Or if you pull a card from a pack of cards, what is the chance that you're going to get a spades? Or you might hear things like, it may rain today, or it's highly likely that our team will win the football match. In all these events, there is some uncertainty. There's randomness because we are not sure of the result. And for this, we use the concept of probability. Probability is a measure of uncertainty, and it's going to be the topic of this video. I'm going to make the concepts really easy for you. And after the video, be sure to try the quiz and the top 3 questions on this topic. Links are given below the video. Let's start with the coin. If you toss a coin, what is the chance of getting a heads? It's a 50% chance, right? The probability of heads is 50%. And 50% is 50 by 100. So that's half or 0.5. Now when you toss a coin, there are 2 possibilities or 2 outcomes here. It could either be a heads or a tails. And we want heads. So one outcome is in our favor here. So probability of heads is going to be 1 by 2. The number of favorable outcomes divided by the total number of outcomes. So probability is 1 by 2 or 0.5 or 50%. Usually in probability, we use fractions. So we write usually probability is 1 by 2. Half. Now the assumption here is that the coin is not biased or it does not get stuck on the edge when it falls. Since our coin is not biased, both heads and tails are equally likely outcomes. Equally likely outcome means that when you toss the coin, there's an equal chance of getting a heads and getting a tails. Tossing the coin is called the experiment. Now let's say you toss a coin 100 times. You might expect to get 50 heads and 50 tails. But let me ask you, do you think it's going to be exactly 50 heads and 50 tails? Probably not. You might get something like 55 heads and 45 tails. But let's say you toss the coin many times. Let's say 1,000 times or even more. Then what do you think you're going to get? And you know, mathematicians actually tried this. They tossed the coin many times. And what do you think they got? About half the time they got heads and half the time tails. So let's say you toss a coin 1,000,000 times. You're going to get 500,000 heads and 500,000 tails. So the formula that we learned, that probability is number of favorable outcomes divided by the total number of outcomes, correctly predicts the result of the experiment. Now let's look at a dice. Let's say you're playing a game like Monopoly or Snake and Ladders and you need 5 to win the game. Oh, I didn't get a 5. Now what is the chance of you getting a 5 when you roll the dice? Here there are 6 possibilities or 6 different outcomes in a dice. It can be 1, 2, 3, 4, 5 or 6. And each number, each outcome is equally likely. Now we want 5 to win the game. So the number of favorable outcomes is just 1. But the total number of outcomes is 6. So what will be the probability of getting a 5? You can use the formula. Probability is the number of favorable outcomes divided by the total number of outcomes. So it's going to be 1 by 6 or 16.67%. Now let me ask you, in a dice, what is the probability of getting the number 2? That's right. It's again going to be 1 by 6. Now how do we get that? Let's again use the probability formula. The number of favorable outcomes divided by the total number of outcomes. So it's going to be 1 divided by 6. So the probability of getting a 2 in the dice is 1 by 6. Now what is the probability of getting an even number when you roll a dice? That's right. The probability of an even number is half. Now if you look at a dice, the total number of outcomes is 6. And what are the favorable outcomes? It's going to be 2, 4 or 6 because we want an even number. So the number of favorable outcomes is 3. And the probability of getting an even number is going to be the number of favorable outcomes divided by the total number of outcomes. So that's going to be 3 by 6, which is equal to half. In probability, we use the term event. Here, event is getting an even number. So we write probability of an event, which is denoted by PE, is the number of favorable outcomes divided by the total number of outcomes. And that's our formula of probability. Let's place the probability formula on our concept board. Probability of an event denoted by PE is equal to the number of favorable outcomes divided by the total number of outcomes. When you roll a dice, what is the probability of getting a 7? That's right. The probability of getting a 7 is 0 because it's not possible to get a 7 because the dice has only numbers from 1 to 6. So the number of favorable outcomes is 0 and the total number of outcomes in a dice is 6. So the probability of getting a 7 is going to be 0 by 6, which is 0. So this is called an impossible event because it's not possible to get the number 7 on a dice. When you roll a dice, what is the probability of getting a number less than 10? That's right. The probability is going to be 1 because the number of favorable outcomes here is 6 because any number that you get is going to be less than 10. And what is the total number of outcomes? Also 6. So the probability is going to be 6 divided by 6, which is equal to 1. So the probability of getting any number less than 10 in a dice is 1 or 100%. And this is called a sure event or a certain event because whenever you roll the dice, you're always going to get a number less than 10. So probability of any event is a number from 0 to 1. For example, as we saw that when you toss a coin, the probability of getting a heads is half or 0.5. Or when you roll a dice, the probability of getting a 5 is 1 by 6 or 0.167. As you can see, these probability numbers are greater than equal to 0 or less than equal to 1. So we can say that probability of an event PE is greater than equal to 0 and less than equal to 1. Note that probability cannot be negative or greater than 1. Now when probability of an event is 0, we say that it's an impossible event. The event cannot happen. And when probability of an event is 1, it's a sure or certain event. The event will definitely happen. When we roll a dice, as we saw, the probability of getting a 5 PE equals 1 by 6. Now let me ask you, what is the probability of not getting a 5? So getting a 1, 2, 3, 4 or 6, but not a 5. That's right, the probability is going to be 5 by 6. And this is denoted by probability of E bar. So probability E bar equals 5 by 6. This is not getting the number 5. So the event 5 not happening. And this is called complement of the event. And it's represented by E bar. So P E bar equals 5 by 6. E and E bar are called complementary events. Now if you look here, probability of event E plus probability of E bar equals 1. So probability of E bar is going to be 1 minus probability of E. So let's say if some probability of some event equals 1 by 6. So the probability of the event not happening is going to be 1 minus 1 by 6, which is equal to 5 by 6. Now let's take a look at a deck of cards. A deck of cards contains total 52 cards. And there are 4 suits of 13 cards each. Spades, diamonds, hearts and clubs. The spade and the clubs are the black cards and the diamond and hearts are the red cards. Each suit has the number cards 2, 3, 4, 5, 6, 7, 8, 9 and all the way up to 10, and then you have Jack, Queen, King and the Ace card. Now let me shuffle this deck of cards so that the cards get randomly mixed up and we have equally likely outcomes. Now if you pick up a card, what is the probability that it's going to be a spade? So let's see, what do we have here? We actually got a diamond. But let's calculate the probability of getting a spade from a well shuffled deck like this. Here we can use the probability formula. Probability of an event is the number of favorable outcomes divided by the total number of outcomes. So what is the total number of outcomes here? That's right, it's 52 because the deck contains 52 cards. And what's the number of favorable outcomes? It's going to be 13 because the deck of cards contains 13 spade cards. So the probability of getting a spade is going to be 13 by 52, which is equal to 1 by 4. Now let me ask you, if you pick up a card from a well shuffled deck, what is the probability of getting a king? That's right, the probability is going to be 1 by 13 because the number of favorable outcomes is 4. Remember, there are 4 kings in this deck of cards and the total outcomes is 52. So the probability of getting a king is going to be 4 by 52, which is equal to 1 by 13. Now let's shuffle the deck of cards again. And now if you pick up a card, what is the probability of not getting a diamond card? That's right, the probability of not getting a diamond is going to be 3 by 4. To make it easy, first let's find the probability of getting a diamond card. And that's going to be the number of favorable outcomes by the total outcomes. And what is the number of favorable outcomes? It's going to be 13 because there are 13 diamond cards in this deck. And the total number of outcomes is 52. So the probability of getting a diamond card is going to be 1 by 4. Now let's use the formula probability E bar equal to 1 minus probability of E. So the probability of not getting a diamond card is equal to 1 minus the probability of getting a diamond card. So that's going to be 1 minus 1 by 4, which is equal to 3 by 4. So the trick is to find the probability of the simpler event. In our case, it was finding the probability of getting a diamond card. And then you can easily find the probability of not getting a diamond card using 1 minus probability of the event. As we saw, the probability of an event PE is greater than equal to 0 and less than equal to 1. The complement of an event is represented by E bar, and probability of E plus probability of E bar equals 1. So the probability of complement of the event, that is probability of E bar, equals 1 minus probability of E. Let's look at another example. Let's say a coin is tossed 2 times like this, or 2 coins are tossed together. What is the probability of getting 2 tails? That is, tails both times. So let's use our formula. Probability of an event is the number of favorable outcomes divided by the total number of outcomes. Let's list down all the possible outcomes. So it's going to be heads, heads, that is heads in both the coins, heads, tails, tail heads and tail tails. So the total number of outcomes is 4 here. And what is our favorable outcome? It is tails tails. So getting 2 tails. So the number of favorable outcomes is 1. So the probability of getting 2 tails is going to be 1 by 4. If 2 dice are rolled at the same time, what is the probability that the sum of the two numbers is going to be 8? Again, let's list down all the possibilities here first. So we can make a table. Now each dice will give numbers from 1 to 6. So what is the total number of outcomes here? It's going to be 6 into 6. So that's 36. And what is the number of favorable outcomes? That is, the sum of the two numbers should be 8. So as you can see from the table, the number of favorable outcomes is 5. So the probability that the sum of the two numbers here is 8 is going to be 5 by 36. How can we calculate the probability that it's going to rain today? Can we say that there are two possible outcomes here, rain and no rain? So using our formula, the probability that it's going to rain today is going to be the number of favorable outcomes by the total number of outcomes, which is equal to 1 by 2. Now, will the chance of rain always be half or 50% as our formula predicts? We know that's not true, because there's more chance of rain during the rainy season and less chance of rain during a dry summer. So what's wrong here? The reason is because the two outcomes, rain or no rain, are not equally likely. So we can't use this simple formula here. The meteorological department gives us the probability of rain on a day, and they do this using current and past weather data. So they do some fancy calculation and statistical analysis based on this data and predict the probability of rain on a day. For example, they may say that the probability of rain on a day is 80%. This means there's a high chance that it's going to rain. So you should take your umbrella. But remember, the prediction need not be accurate because there's always some uncertainty here. Let me ask you an interesting question. Let's say your birthday is in December. What is the probability that your friend's birthday is also in December? Do let me know your answer by putting it in the comments below. I hope the concept of probability is crystal clear to you now. So the probability of you doing well in your tests should be 1 now. And do try the quiz and the top 3 questions for this video. Links are given below. And do remember to like, comment and share out this video. And if you haven't subscribed to my YouTube channel, hit the subscribe button right now. You can also check my Facebook page and do check out my website, manochaacademy.com. And don't forget to try my birthday question, which was, let's say your birthday is in December, what is the probability that your friend's birthday is also in December? Do write your answer in the comments below. Thanks for watching.